Stonehenge Underground. New technologies in geographic information systems, land surveying, and archaeology combine to expose the real Stonehenge. July 2010, land surveyors, archaeologists, and scientists from Birmingham University and Ludwig Boltzmann Institute began a 4-year project to collect data and map underground structures around the Stonehenge Monument in Amesbury, United Kingdom. On September 29, 2014, Crispin Andrews published an article in Engineering and Technology magazine summarizing the Stonehenge Hidden Landscape project. This circle of rocks is what people usually think of when they hear Stonehenge. It is the largest above-ground monument on the site. Few are aware of the vast array of monuments, buildings, ceremonial objects, and burial sites that lie underground. The Stonehenge Hidden Landscape project set out to digitally image and map the acres of other structures that cannot be seen with the naked eye. This is a rough project outline, beginning with data collection. Magnetometer surveys, ground-penetrating radar, and high-accuracy GPS and total station positioning are used to collect data. Then it must be imaged, using the magnetic data, raster data, and integrating GPS and total station data. Next, the data interpretation, requiring a GIS. This project required a custom-designed GIS because of its magnitude, and it was used to organize the data, confirm its accuracy, and georeference the data in 2D and 3D environments. And finally, the GIS output is a usable product. Here, data collection is done using electromagnetic induction measurements, which is being towed behind a quad, and a high-resolution cesium magnetometer, which is much slower and used for higher resolution, smaller images. Also, motorized ground-penetrating antenna array is used to get much higher resolution images, and high accuracy GPS positioning is used to help position and georeference all the data. Here are a couple images from the magnetic data. From these you can get a good idea of shapes, and you can tell that it's a different material than the ground around it. Here are a couple more magnetic data images. On the left, magnetometer produces digital raster images at a resolution of 10 by 25 centimeters. And on the right is ground-penetrating radar image, which is used where magnetometers found points of interest for a much higher quality image. The GPR produces images with an 8 by 8 centimeter resolution and gives detailed information about depth, shape, and location of interesting objects. From there, the data needs to be interpreted. Each magnetometer used collected 50 to 150 megabytes of data each day, while the GPR collected 2 to 4 gigabytes per day. To process the data, verify its accuracy, and produce a usable product, a geographic information system would be needed. It's not always so easy. Normally, with a smaller scale archaeological investigation, researchers would input the raster data into a GIS environment and enhance the points of interest manually. With such a large data set, a means of automatic or at least semi-automatic data classification and arrangement would be necessary. Alois Hinterleitner, who is an ArcPro specialist for the Ludwig Boltzmann Institute, developed a custom software to process the immense volume of data that the Stonehenge Hidden Landscape project produced. With the new software, researchers could more easily process and georeference the 2D and 3D raster data. Hinterleitner's software also expedited data collection by visualizing measured data on a screen in the field. Researchers then had the ability to filter data and know what areas had been covered in real time instead of waiting for post-processing. Here, an operator uses the screen as he collects data. Next is georeferencing. This shows georeferenced magnetic data outlining Durrington Walls Superhenge. This is a newly discovered ritual monument which has a circumference of 1.5 kilometers, dwarfing that of Stonehenge. And finally, a usable product. This image shows an overview of the 12 square kilometer finished product. The map shows a hillshade of the current surface with previously known and newly discovered monuments highlighted to show location. From the refined data, maps can be made for any intended purpose, whether it be archaeological, tourism, educational, etc. Geographic information scientists are used to working with experts in other fields to create a usable product from raw data. Projects of this scale, however, are few and far between. For this reason, a custom-built GIS was necessary to handle the immense amount of data that was collected. The well-designed system's ability to filter, organize, and verify data was a major reason that the Stonehenge Hidden Landscape project was a success. It proves that geographic information systems have advanced in their ability to handle more diverse applications, and it opens even more doors to what it can do in the future.